Hi, I'm Jared. Welcome to Fun Science Demos. The big idea today is erosion and how water has the power to shape our land. But we don't want the water to shape our land too much because we need that soil to grow plants. We use those plants for food and animals use those plants for food. So what you see in front of me are three different types of land. This first type is just bare soil. It's just soil. This next type has dead leaves on top, and the third type has plants growing in the soil. This may not look too exciting right now, but when it rains, that water has the power to change the land, and we're going to make it rain to see what that water is going to do to our land. So we cut the top off of 3 plastic bottles, and we put the same soil in each of those 3 bottles. All of these bottles have the same soil. We covered this soil with dead leaves, and we grew some plants in this bottle. We've also used other plastic bottles to catch the water that's going to come out of these when we pour it into the bottle. We want to pour water into each bottle and see what happens. Does that water have the power to change the land? What do you think is going to happen when we pour water into this bottle and it comes out into the cup? Will it be any different from the water we pour into this bottle as it comes into the cup? And will this one be any different when we pour water into this bottle and it comes out into this cup? So I'm going to slowly pour water in. You're going to see the water level rise, and we'll see what happens with our soil. We'll keep it coming. And now it's coming out. Take a look at the bottle we used to catch the water. Well, what do you notice? Well, it's cloudy. So why is it cloudy? That's because all the dirt and the soil from our bottle was washed into the cup. The water had the power to actually take the dirt and the soil with it out of the bottle and into the cup. The water moved the soil. It shaped the soil. So now I'm going to pour about the same amount of water into the next bottle. What do you think is going to happen? The water that we catch, will it be just as dirty? Will it be less dirty? Will we even be able to see a difference? Well, let's pour the water and find out. Here we go. So I'm pouring the water in. Making it rain. Adding water to our bottle. I can see the leaves floating to the top. Do we have any overflow? Yes, we do. Stop the rain and see what we have. So we've zoomed in so you can compare the two. This one has a lot of the soil in the container. This one just has a little bit of the particles, a little bit of the soil in that water. So why do you think this container is a little bit cleaner? Well, what's different between the two? Well, this one had leaves, dead leaves on top, and I think most of these dead leaves helped protect the soil underneath from moving with the water. So what do you think is going to happen with our third container? We have plants growing in the soil. What's going to happen when we add water and make it rain in this container? All right, here we go. Let's add the water. About the same amount. Pouring the water in. What do you think's going to happen here? Add a little bit more. Coming out. We're going to stop pouring and see if we can compare what we see coming out. The water coming out of this container looks a whole lot cleaner than this one and a little bit cleaner than this one. So the question is why? Why is this water cleaner? I poured about the same amount of water into each container of soil. This one looks really clean. Well, to answer the question why, we have to zoom in and take a closer look at what's really going on here. So now we're all set to take a closer look at why the water coming out of this bottle was so clean and clear compared to the others. To do that, I'm going to actually lift these plants out of this bottle and let's see what happens. Well, what I notice right away is what comes along with all of the plants. Well, the soil is actually coming out too. When I flip it over, I think you'll be able to see why. So we've zoomed in so we can see what's going on here. Why is this soil staying together? Why is it staying in place? Well, you can see the roots from our plants grew into the soil, and almost like little fingers, those roots are holding the soil together. So when it rains, the roots keep the soil from washing away. The roots of the plant, that's what keeps the water from eroding the soil. Besides holding the soil together and in place, roots do another amazing thing. To show you that, I'm going to squeeze this and I want you to watch what happens. Where did all that water come from? Well, that came from when we made it rain on our soil. The roots of the plants helped hold that water in. Plant roots actually go deep into the soil, and this model is going to help us see how deep they can go. We're going to zoom in and see if we can see those really tiny plant roots that we have growing in our soil. We've zoomed in now so you can see these tiny roots in action. I'm going to point them out, and they actually extend from the plant all the way down to the bottom of our soil. I'll point out some of the bigger ones. They grow down into the soil. And think about what they're doing. They're holding that soil in place. All of these tiny roots getting nutrients from the soil, but they're also helping the soil out. Plants do an amazing job at keeping erosion from washing away too much soil. We need that soil. We depend on that soil to grow plants, and animals depend on that soil to grow plants. If you want to learn more about plants and soil and erosion, check out our links in the video description. Science is so cool, and sometimes it's dirty. Thanks for watching.
The ultimate goal of farming is not to grow crops, he writes, but it is the cultivation and perfection of human beings. To allow the soil to build fertility on its own by accommodating the habitats of beneficial organisms native to that soil. Straw. The revolution is in its simplicity. By keeping a layer of thick mulch over the soil, I am allowing for generations of tiny organisms to develop, flourish, make castings, reproduce, and then die. Within one season alone, these microorganisms deposit an astonishing amount of organic matter into the soil, enough to match the following year's supply of fertilizer, had I chosen to till. By protecting the ground from direct impact with rain, I am also preventing the compaction and erosion of soil minerals. The blanket of mulch regulates temperature. I am also suppressing weeds. Each weed I pull out by the root will likely never come up in that spot again, as long as I choose not to till.
They're best like right off the vine.
More mulch is applied to protect from erosion. The result is an ever-increasing level of fertility with a decreasing energy output by the gardener. Plants can be allowed to die and decompose where they grew. The natural farm.
So the forest really gardens itself.
And here, when we uncover just a piece of the mulch, we see this fluffy, really fine humus. It's a really nice loam, great drainage, and it was never tilled. There was always just a layer cover of leaves that would just fall from the trees. Let's go check out what the no-till garden looks like now. I haven't watered in 2 days, and the soil underneath is very, very similar. It's fluffy, it's wet. There was really no tilling that happened. I planted clover in the path just so I could
Later.